start saving my broadcast, because one time I thought, oh, I'm just gonna start saving this just at the moment I start, and I forgot. So not this time. I'm gonna put it on YouTube later, I think, because the stream is saved for only 2 weeks on Twitch, I think. So okay. Go. Inner space images. Whatever that inner space in the home, or inner space in the head, something. I'm curious who will be here. Probably a couple of people from the Weekly Space Hangout crew. The human body. Okay. I also announced the live stream on the Discord server for the Skeptic Guide to the Universe on Twitter, on my Twitter account, and on even a history account, because there was a history podcast, the Renaissance podcast, and they talked about the same goddesses I'm going to talk about. And talking about which, I think I should get starting, because it's 21 hours sharp here in the Netherlands. So yeah, welcome everybody. I am going to talk about the planet Venus, and first I'm gonna tell something about myself. While my image of my webcam, I'm gonna completely all the time keep dragging my image in this and that corner because it's overlapping something on screen. Yeah, so I'm Marcel-Jan Krijgsman, also known as Baryonic Man on the Weekly Space Hangout crew Slack channel and some other channels. And I am from the workgroup Moon and Planets of the Royal Netherlands Association for Meteorology and Astronomy, or the KNVWS. It's quite a mouthful. I write about space, about the solar system for our Moon and Planets, but in Dutch, Moon and Planets.nl, Maanenplaneten.nl, and I just try to show everybody that we exist, and by showing what's happening in the solar system. If you want to, but that blog is in Dutch, unfortunately for most of you. I tweet in English on my own Twitter account, Marcel-Jan Kr, and sometimes about space. Also, often about my actual job. I'm a data engineer. I'm not even an astronomer. I just do this for fun. There's nothing wrong with that. Yeah, so I have a story about the planet Venus, and I like to start my stories about astronomy sometimes way back in the past. I like to imagine the first human beings looking at the sky, and they didn't have a manual. There's nobody who told them, well, a year is 365 days long, and the moon comes about every 12 times per year, and this is the winter, this is summer. So they just had to find out, this is the season that we get a lot of food, and this is the season where we don't have a lot of food, and it depends on how high the sun is in the sky and that kind of stuff. And and gradually they learned more, and you can imagine that they were thinking, hey, when I look at the night sky, I see a couple of these bright dots moving different from the rest of the stars. What's up with that? And well, they seem to have associated them with gods, like this one. This is a very old one. This from Summeria, on a shard of pottery. This is Inanna, and she is the goddess associated in Summeria with Venus, the planet Venus. She looks kind of nice here, but you have to if you look a little bit closer, she has a crown with horns, and the things she has behind her shoulder are weapons of some kind. So she is actually not really that Pippi Longstockings you might think she is. And that became even clearer when the Babylonians, she kept existing but got a different name. At some point she was called Ishtar in Babylonia. And this is an image from a seal from that time. And she really looks like a lady you don't want to have a big argument with. Really seems to be imaged based on somebody's ex or something. She has, again, a crown with horns. She has wings of a hornet. She steps on a lion in this image, and she also has all kinds of weapons on her back. And upper left is a 8-pointed star, and this is the planet Venus. And why 8-pointed? I don't know, but it's probably because it is so very bright in the night sky. Back to this screen. Now, later on, I have to move my image every time, my webcam image. Later on, people started observing the night sky a little bit more with in more detail. The Babylonians started writing down when they saw Venus set and rise, and here I have to get myself out of the way of the notes. Yeah. So this is the Venus tablet of Amisaduqa or something. But it says here, my cuneiform is rather rustic, but it says year 1, Venus it sets on that day of that month, and it rises on after so many days, and then on year 2 it vanishes east on that day and that month, and so on. And that they kept this log for 21 years. And if that sounds kind of interesting, but even an even extra interesting thing about this tablet is this is a copy of the original one made 1,000 years later. Apparently, people in 700 BCE thought, wow, that is super interesting. Let's make a copy of it. And and write it down again. So there's that. And this is basically what they've done. This is what you see when you watch a planet across the sky. This is Venus, according to nakedeyeplanets.com. You get to see Venus rise. You could see it rise in November last year. And it doesn't have a nice half circular path, because Venus is moving in the inner row in the solar system. It's in the inner orbit, so it's taken over us, and then so it has it moves faster later in the year. Near May, it's going super fast through the sky, and in late May, this month actually, it will be below the horizon. Another interesting thing is that the Sumerians and the Babylonians, they were sure that Venus is just one object. It's whether it's in the morning sky or the evening sky, it's basically the same thing. But not every civilization realized this. For example, the ancient Greeks, at first, they had two names for this planet. They had Phosphorus for the morning star, and Hesperus for the evening star. And even after they found out, and some say because it was because of Pythagoras told them so, other people say it's Parmenides that said that it was the same thing. The Romans kept having two names for the morning and the evening version of Venus. They were calling it Lucifer for the morning star, the light bringer, and Vesper for the evening version of Venus. So the whole name of Lucifer later became the devil. It has something to do with Venus being consumed by the fire of the sun and all that kind of stuff. There's all kinds of mythical stuff around that. But that's where these names come from. It's kind of interesting. But the Romans eventually named the planet Venus. The Mayas were super interested in Venus. They not just created a temple for Venus, like this one. They really were keen on observing the planet. And what they did is they just did not just look at how, in what time Venus went around the sun, which is the sidereal period, but they looked at the synodic period. And I had to look that up, what that was again. So basically, a synodic period is when two planets around a star align again. And this takes much longer because Venus goes round and round, but probably they didn't look at this this way, because then they would have to look at Venus against the sun. They looked at when Venus was in the same constellation, in the same part of the sky. And this actually, the Mayans were very accurate in calculating this. They said this took 584 days. And they were pretty spot on. Actually, the real synodic period of Venus is only less than a half a day less than that. So they were pretty good at that. So they must have been really serious about observing Venus to find that out. Well, after that we could go straight to the time of the telescopes, but I'm gonna take a little detour in between to this person, a universal scientist from Persia, Ali ibn Sina, or as they like to pronounce it in the western parts of the world, Avicenna. And he said he saw Venus go across the sun. He saw a hole in the sun, he said. And sure enough, during his life, there was a transit of Venus in front of the sun, and it would have looked like this. A while back, a couple of years back, they were trying to find out, could Avicenna actually have seen this from Persia? Because transit from the sun, you can only see it from a certain part of the world when it happens. And sure enough, he was able to see it, and he probably has seen this transit of the sun at sunset, when the sun is a little less brighter. Because I was already wondering, where are his eclipse glasses? But he was able to see it this way, and we'll have to deal with it. Now we get to the part where the telescopes are used. Galileo did not just find out about the 4 Galilean moons around Jupiter and the strange ears of Saturn that later turned out to be the rings of Saturn. He also saw the phases of Venus, because Venus, like the moon, has phases. This is because Venus is in an orbit around the sun, like Earth, but is close to the sun and moves faster. But that's not the part here I'm going to discuss. What I want to say is, when Venus is almost at the other side of the sun, it's completely lit. And when Venus is very close to the sun, close to the Earth in its orbit, it's almost completely, we only get to see the dark side. And this would not have happened if everything was revolving around the Earth. Not like this anyway. And you can actually see this with a telescope. And I know some people from our work group who post their images of Venus regularly. You can see that the crescent of Venus is getting smaller because Venus is getting closer to Earth at this moment. It's pretty close at this, actually. Yeah, so there's that. So back to transits of Venus across the Sun. It was Johannes Kepler, Johann Kepler in English, probably. Kepler said had calculated that the next transit of Venus would be in 1631. But unfortunately, he made a little bit of a calculation error. Nobody was able to see it. And he wasn't around to see it himself because unfortunately he already had died. But in 1639, Jeremiah Horrocks was able to see it for the first time. Also, and his friend William Crabtree, both from their own homes. They must have looked at it something like that. This is according to a painting that was made later by Eyre Crow. So the telescope would project, the sunlight would be, the light of sunlight would be projected inside the home of Jeremiah Horrocks, and he was able to see Venus going across the sun. He also made a drawing of it. This is what it looked like, according to him. So this a couple of people started to think, hey, these transits of Venus, we might be able to use this to answer some questions we have about the solar system. Now, let me put myself somewhere so I don't eclipse Edmund Halley. Edmund Halley had an idea about this. He said we could use this to calculate the distance of the Earth to the Sun. Of course, there was a question that they had at the time. They didn't know how large the solar system was. But actually, he forgot to tell that he got the idea from a mathematician from Scotland, James Gregory. And James Gregory actually came up with the idea much earlier that we could use this math to do that. So what was the idea about this? Well, basically, this is of course not the scale, but this is what you could say sort of looked like. This was sort of the idea. So you have Earth, Venus, and the Sun, and Venus transits the Sun. But when you look from different places from Earth, you can see Venus transit at different places across the Sun. So the idea was that if you have the distance between these points on Earth, which they were able to calculate, and you have the angle between these points, you can calculate the distance between Venus and Earth. And because Kepler had already calculated the relative distances between the planets and the Sun, you could calculate the whole deal now. So you could also calculate the distance Sun-Earth. So that's what they did. To put in a little bit more math, basically you create a triangle like that. I'm not so good at English mathematic terms, but basically you get a triangle where you can use a sinus function to calculate the distance Venus-Earth, and it would look something like this. So this is basic trigonometry, and this is what they would set out to do at the next transit of Venus. There was also something else to be gained. You can also calculate the size of the Sun with this, in this way, with a little bit more math. So very interesting, very useful, and they set out to do this. Unfortunately, when they first tried in 1761, it didn't work out so well. Something like bad observing conditions, something like that. I remember from the top of my head. But while that was happening, there was a Russian observer, Lomonosov, and he discovered that discovered something else about Venus, and that is that Venus had an atmosphere. And it was only 8 years later, because these transits come in pairs of two sets with 8 years in between, and then 241 years, I think, or 245 years before you can get another try. Long story short, 8 years later they tried again, and for this, no other than Captain James Cook went to the southern hemisphere, and he went to the island of Tahiti, which hadn't been discovered all that long before. These are drawings. I'm not sure Captain Cook made them or whether the astronomers on his ship made them, but this is what it looked like. And this is what his travels looked like. James Cook had been on the seas for 3 years before he got back in Plymouth. So he went all the way around South America to Tahiti. They stayed there to do the observations. Then on the way back to Plymouth, he went past, found out about New Zealand, which hadn't been discovered at the time, that he discovered it. And then all the way along the Indies, as they would call it, to South Africa and back to Plymouth 3 years later. It was an amazingly long voyage, but they thought it was worth it. Actually, the observations weren't so not good enough yet, but they got better. What also got better were the telescopes. But sometimes people see things that are not exactly there. And these are drawings by Percival Lowell, astronomer and the founder of the Lowell Observatory in Arizona. This is he said he saw spokes on Venus, and it was not just his mistake. His people in his observatory also took a look, and they said, "Yeah, we can see spokes on Venus." But of course, we now know that they weren't actually there. But to give an idea of what we thought, what we could see back then, I have a book. I'm not really a collector of old astronomy books, but I start now. I have found a book. I bought a book a year ago, something like that. It's a Dutch book from 1910, and I want to talk to you about what's in here about the planet Venus. There's a chapter on Venus, and it says, this is just to give the idea what we were thinking Venus was like in 1910. So it says, Venus is similar to in size to the Earth, and it has an atmosphere which almost completely consists of the same stuff, the same chemicals that the Earth atmosphere has. There's a lot of water vapor in it, it says. Well, this is not true, actually. And it's almost covered by mists, nebula. We can't see the surface. It says only once in every few times there is we get a little bit of a peek through the atmosphere. I don't know how, because you can't do that in visible light. And we can see the surface of Venus. And whether we see the large oceans on Venus or something else, we don't know yet. The book goes on. The story goes on. So some people, some observers, some astronomers say that they see these spots on the Venus atmosphere. And but anyway, what they were able to gain from that is that Venus rotates once every 24 hours, which is definitely wrong. Then it gets even more interesting. It says someone no less than the famous astronomer Schiaparelli, you know him from the Canals on Mars, in 1890 told that he thought that the rotation of Venus should be much longer, something like 225 days. And but it later says other astronomers told him wrong, and they were back to the idea that Venus would rotate every 25 and every 24 hours, which is really interesting. And I have a picture here. I will enlarge the image of the webcam a little bit. I hope you can see this. This is these are the spots on Venus. Spots on Venus, drawn by I have to see who. Oh, this is the astronomer called Vogel, a German observer. Also, this book also has the canals on Mars, drawn by Schiaparelli. So this is really cool to see these things. I really sometimes I really like to read these old books about astronomy. So I'm gonna make myself smaller again. So this is what they were thinking about the planet Venus back then. But things were about to change. And as we said in the in the 21st century, we get to see a couple of astronomers that probably very few people have heard about, but they discovered a couple of interesting things. These are Walter Adams and Theodore Dunham, and they were observers on the Mount Wilson Observatory in California. And they used spectroscopy to see what the atmosphere of Venus is like. And they found out it consists of a lot of carbon dioxide, according to the infrared spectrum. So this is getting interesting, but nobody realized what that meant at the time. And actually, people didn't keep realizing that at the time for much longer, because this is on the left side. You can see The Man from Venus from a popular, well, more kind of sci-fi book from 1939. And the book goes on in a page, turn the page, about what kind of things you have to wear when you land on Venus. You need leather boots, and you maybe need some mask for breathing, but you're probably good. And of course, the Venetians look like every alien, have 2 arms, 2 legs, 2 eyes, and mouth. But they have webbed hands and webbed feet, so they can swim faster in the enormous oceans on Venus. Now, if you think this is ridiculous, okay, sure. This series of books also had The Man from Pluto, and that's pretty silly, actually. But later on, you get an English movie called Stranger from Venus. And on the right side, you see a drawing from the Soviet Union in the 1960s, when the space age was truly well started. And you get to see how human beings land on the oceans of Venus, still the oceans of Venus. And I have to give them points for the most imaginative aliens, Venusians I've seen so far. These are definitely not the 2 arms, 2 legs kind of variety of alien life. So this is really what people were thinking Venus was like for a long time. But there was one astronomer called Rupert Wild, another guy that I didn't know about before I started reading into this. And he started calculating what these amounts of carbon dioxide would actually mean for the temperature on Venus. And he found out this means that water would boil. The temperature would be higher than the boiling point of water. But people didn't give it a lot of thought at the time. Still, we'll see. He wasn't wrong. This is another astronomer that I didn't know about. It's actually not sure what he found out about Venus. I have known it for some time, couldn't find it back, but he had a very unusual way of observing Venus. He took a telescope in a balloon gondola with him. This man is Edwin Dolphus, and he still has the altitude records for ballooning in France. He was a French astronomer, and he went on a string of 102 balloons to the stratosphere, and I read that the way to get back was to shoot the balloons one by one to get back to the surface. So I'm not sure how we could get stable observations from from this platform, but it's pretty interesting. He, if you see French balloons in the atmosphere of Venus later on in my presentation, I think he had a hand in this. And then something else we found out we could do from the surface of Earth is we can use radar. So this has been done with the Goldstein's Goldstone radar in California from the Jet Propulsion Laboratory. And this looks like already like a nice map you can make. Well, then the space age started. And we soon see that there were a lot of attempts of viewing Venus from more closely. That already started with the Soviet Union. This was not the first attempt. The first attempt crashed. The launch didn't go right. But Venera 1 was the first attempt to send something that actually went on its way to Venus. This is what it looked like. And unfortunately, the probe wouldn't respond when it flew by Venus in 1961. But the Americans were more successful in the next year with Mariner 2. And they did a couple of interesting measurements, among which the temperature on Venus. And it turned out it was actually rather high. On the right side, you can see the printout of all the data they gathered, which was the style at the time. And yeah, they found out that the temperature on Venus on the dark and the night side was actually something, according to them. Oh, and there's my backup. Let's not do that one at this moment. They found out the temperature is something like 270 degrees Celsius or 422 degrees Fahrenheit. Actually, turned out later it's much higher, but this was already reason for concern. And the interesting thing, one more thing, this is what they actually could do back then in the 60s. You could go to the White House and talk about science, apparently. Long ago. Yeah. So there's the Soviets. The interesting thing about the Soviet attempts at landing on Venus is that they were every time they seemed to have been a step behind to the actual science findings. So while the Mariner found out that, hey, Venus is actually rather hot, they were already building Venera 3 with a probe, which is on the solar sail on the right side. And this thing was actually built to float on an ocean. So still in the 1960s, the Soviets were counting on that it was possible that they had to land on an ocean, and they had to need to create a probe that actually could do that. Well, it went to Venus, but unfortunately the probe didn't respond, because even while it wouldn't have found an ocean to float on the way through the atmosphere, we would have had some interesting readings. But space is hard, but the Soviets kept trying. The next time they sent Venera 4, and here again they said, okay, we'll create a probe that can sustain much higher temperatures and higher pressures, because there were already concerns that the pressure in the Venus atmosphere was rather high. So they created a probe that could survive a pressure of 25 atmospheres. So that's something like 25 bars. I don't know in PSIs, but it's about 25 times the pressure at sea level on Earth. And as we later will see, that was not enough. But good attempt. They actually managed to get some information, some measurements from this while it went through the atmosphere. Then, the same year, actually this day later, Mariner 5 from NASA passed Venus, and it found out what the actual pressure on Venus was, and it turned out to be much higher. Yeah, more like 75 to 100 atmospheres, so more like 75 to 100 bars, about that. So about the pressure you can expect in the ocean on a depth of 1 kilometer, or How many miles is that? Half something. Anyway, pretty dense atmosphere and temperatures of up to 527 degrees Celsius, and that's something like 1000 Fahrenheit. It's pretty high. So and next so the Venera 4 wasn't up to that, but the Soviets kept building new probes to try to land actually land on the surface. So Venera 5 and Venera 6 were launched in 1969, and they managed to survive up to 10 kilometers altitude. Better, but still not the surface. It was only in 1970 when Venera 7 which was built even more badass, that it managed to reach the surface. But actually on landing, it seems that it failed. And it turns out that the antenna was kind of bent or something. And it was only in 1972 with Venera 8 that they managed to land on the surface and keep sending signals. So this was what Venera 7 looked like. And that thing on the upper left, that kind of strange metal thing that's hanging out, that is probably, I think that's the high gain antenna. And this was bent on landing, and they thought, well, we don't have any data after landing. And later they found out in the radar data, they had a very weak signal of the probe sending data 23 minutes after landing. So they still managed to get a lot of information from that. But in any rate, they found out something about the atmosphere all the way to the bottom of it. They found out there was sulfuric acid in the atmosphere. It's raining sulfuric acid on Venus. And you can also see, it's really weird. So the surface is incredibly hot, but the upper atmosphere, it can be incredibly cold. When you go through the atmosphere at something like 70, 80 kilometers, suddenly it's minus 100 degrees Celsius or less. And when you get through lower atmosphere, then suddenly we go all the way to 460, 470 degrees Celsius. NASA kept sending probes to observe Venus from afar, like the Mariner 10, which was went past Venus and Mercury, and it had an ultraviolet camera. And this could show something else about the atmosphere. I have a better shot here. It can show the winds, the clouds in the atmosphere of Venus, but you could also see the atmosphere of Venus moving. The Soviets kept trying, and I've been wondering why, actually, because, okay, so they landed on the surface of Venus and they found out it was a hellhole. Why keep investigating a hellhole? Well, actually, there were more political reasons for this, I found out. I was reading about this, and they basically said, well, they didn't outright say, well, Mars is hard, but they said we can only lose at Mars and we can only win at Venus. Now we know how to land. So they started building a lander that was of a new type, which was 5 times heavier than the Venera 8 and 7. And it looked like this. It's actually interesting when you read how this thing landed. You read that it went through the atmosphere with a heat shield, so it would dissipate the orbital speeds, and then a parachute would pop out and it would slow down a little bit more, and another parachute would pop out, and then at 50 kilometers altitude the last parachute is released, and you're thinking, am I missing something? Where's the next parachute? There isn't any, because this funny head the lander has is actually the way it slows down through the atmosphere below that, and this is just enough to let this lander land at a pretty nice speed of 25 kilometers per second. So it's something like, imagine running your bike against a wall. Well, it's not good for you, but when you have a cushion, the cushion ring like this one has on the bottom, you can actually have a survival of a lander. So that's what they did. This is the Venera 9 and 10. This is how it was stored. It was in the bulb up top of the mothership, and it did not just land. It also had a camera. It had two cameras actually, but this was an image from one of the cameras, and so you can see here it has rocks. But we also have an image from Venera 10. This looks differently. This looks like this. And by the way, you can also see these probes from the lander against the surface. This thing here, I hope you can see my mouse, that T-shaped thing here, that is a thing that can measure the components of the rocks on the surface with a gamma ray spectrometer or something. And yeah, oh, by the way, they both had two cameras, but we don't get to see the images from the other side because the camera lens cap wouldn't pop off. And this is a problem they had afterwards with other landers as well. So that sucks. You might go all the way to the surface of Venus to find out one of your cameras won't be able to make any images. Anyway, they kept sending landers. They actually send a lot of landers. If you take in account all the successful landers that from the Soviet Union that went to the bottom of went to the surface of Venus, they had 10 in total, and most of them were these funny head-looking landers, the later Veneras. So we had Venera 11 and 12 in 1978, and they did have two cameras from which the lens cap wouldn't come off, so we don't have any images from that. And then we have Venera 13 and 14, and I'll talk about these more later on. Oh, these were the temperatures, and fortunately only in Celsius. Just suffice to say that it was pretty hot. But it also tells you how long the probe survived, and the Venera 13 survived the longest, 127 minutes, so more than 2 hours. The thing is, these were didn't say something about the probes that survived. This didn't say anything about the quality about the probes per se, but also how soon the mothership that would relay the data would be out of view. So that's basically why, for example, Venera 13 couldn't transmit longer. And as soon as the mothership would get into view, because some of these motherships were orbiters, the probes would have died anyway because of the harsh conditions. So they would not survive that long. The Americans also gave it a try. They sent two probes in 1978. The Pioneer Venus. One was an orbiter, and the other a satellite bus with 4 atmospheric probes. They were meant only to send data about the atmosphere back, and not from the surface. But the funny thing was, actually, the larger one managed to survive, to their surprise, for something like a half an hour on the surface. So this was pretty good. Yeah, and this was the radar image that the orbiter sent back to Earth, and it also sent back images in ultraviolet. So we really had a good view of the weather on Venus, and it looks something like this. And from this, they were able to learn that Venus' atmosphere rotates around the planet much faster than the planet itself rotates. The atmosphere goes round every 4 Earth days, so that's pretty fast. And they only recently found out why that is. It has something to do with the enormous temperatures that creates convection or something. I have to read the article in full to tell the real good tale about that. Venera 13 and 14, they had a lot of extra experiments with them. They also had a drill. Now, to be certain, Venera 11 and 12 also had a drill with them, but they didn't work, unfortunately. But just imagine, this is all working at temperatures of 465 degrees Celsius or something like 900 Fahrenheit. It's amazing stuff. Just to give you an idea how hard it is to build a lander for Venus that will work for a while, these are the things you cannot take with you. These are the materials you cannot use on a Venus probe. One, glass will melt. Anything organic like rubber, that's not gonna work. That is not. That will paralyze or dissolve in the supercritical atmosphere of carbon dioxide. Magnesium and titanium seem like good deals, but they can combust in this atmosphere, because you have to imagine you also have carbon sulfuric acid also raining down, so that's probably not going to be good. Aluminium will melt, lead will melt. Well, I'm not sure what they were exactly built of, but they you can imagine that they had to create special metals, metal alloys for these missions. It's really incredible work what they did. And they had a color camera on Venera 13 and 14. And these images look like these. The horseshoe-shaped thing on the surface is the landscape that this time did go off, which is nice. They also had a color chart, as you can see on the right. And this is the camera, by the way. It would make a sweep of images. And you have to imagine when you land a probe like this, you have to work fast, because you don't know how many minutes you will survive. So everything has to work automatically. It's not like some Mars rovers that land and then take a day, and maybe we're going to drive off, and then we have a look if all the instruments work, and we turn them on one by one. No. Move. You don't know how much time you got. Yeah, so this is and this is from Venera 14, I think. Yeah, so that's pretty amazing stuff. This, another astronomer, Don Mitchell, a couple of years back, photoshopped these images that would look like you would take an image with a cell phone camera, for example, and then Venus looks like this. Unfortunately, we still don't have rovers that can rove on Venus. Oh, hi, Kerbal 01. Welcome. Oh yeah, about this drill. This is another marvel of engineering that almost nobody knows about. They had to create a drill that works at these high temperatures, but it's not just creating the drill with new developed heat-resistant materials and electronics, but you also need lubricants that work at these temperatures. So they had to invent new lubricants that can work at these temperatures. So they came up with things like, molybdenum disulfide and microscopic metal flakes that can melt or something at these temperatures. I'm not sure how that was supposed to work. So that's pretty marvelous. But even more cool is they also had a microphone on Venus, and I think you want to listen to this, because I didn't know that this actually existed. Let me show you, or this is Venera 14. Still going through the atmosphere. Hasn't landed yet. I was so amazed when I learned this. And in a few seconds you will hear a thud, and that's the actual landing. That's the probe landing on the surface. That's the landing. Now, 10 seconds later, or even less, the landscape comes off. That's the landscape. And 20 seconds after that, it starts drilling. And I won't let you hear the whole thing, because after a while, it goes on drilling for a minute. And you don't have to hear all that. That's the drilling. Like I said, working against the clock, keep working. So that's when I heard that I was just flabbergasted that existed. Really cool. We don't have so very few sounds from other planets, and this is one of them. I think it's the only one because we're still waiting for the microphone on Mars to work. Planetary Society has been working on that pretty hard. And the next attempt will be with the Perseverance rover on Mars. It has a microphone with it. Yeah, the ground photos look amazing. It's just so it's just too bad that the probes survive for so short a time, and we'll get around about Venus rovers. I have a segment about that later on. In 1983 and 1983, Soviet Union decided to send something else than landers. They decided to send a radar instrument. So basically, this is the same mothership, but instead of a ball with a lander in it on top, they had a radar antenna. So what they did is they use synthetic aperture radar, it's called. It's basically you're sending a radar pulse down through the atmosphere. It will go through the atmosphere unscathed, and then it sends back, and dependent on the surface features, it will send in different time frames, send the radar pulse back, and you can get idea of how the surface what surface looks like. And this is this was just one spot with a radar passage, and this is a whole map they made it with it. So that was pretty successful with 2 probes. And in 1985 decided they wanted to have landers back again, because why not? I'm really surprised they kept doing this for so long. But yes, Kevlar 1066, we should go back with new instruments, better stuff. But we'll get back to that later on, about when I talk about future missions. Let's have a little bit more light here because it's getting dark, because it's evening here. So in 1985, the Soviets sent Vega 1 and 2 to Venus, but also they were called Vega and not Venera because they also went past they also viewed the comet of Halley's comet. And so they had an observing platform attached to the mothership as well. And not only that, they not only had that and the landers, they also had balloons. These were French balloons. Remember I talked about that French astronomer Edwin Dollfus? I think he had a hand in this one. They both landers had a balloon that they set off at an altitude of something like 54 kilometers above the surface. So still pretty high, but at these temperatures, it's actually they're not that hot. At that altitude, it's not that hot. And this is actually an image this is a photo of myself because this balloon is on display in the it's not the Smithsonian Air and Space Museum, but the other museum attached to it for all the stuff that they can't put on display in Washington. It's in Virginia. It's at that airport. Forget the name. Utvar-Hazy Museum. Oh man, Smithsonian Air and Space Museum and the Utvar-Hazy Museum. They're just I had a ball visiting these. It was on my bucket list for a long time. Anyway, in the same hall that the Discovery Space Shuttle is on display, they also had this balloon, this French Venus balloon. And these both balloons were active for 46 hours, so about 2 days. And during that time, they traveled along the atmosphere, the fast-moving atmosphere of Venus. So they visited, traveled something like 1/4 of the circumference of Venus with it, and they did all kinds of measurements. We should have more balloons in space flight. It's so cool. In 1986, there was one more Venus mission, and this one by NASA, and this is the Magellan. It was launched on a space shuttle, as you can see here. And back then, I was just starting to get more and more interested in space and astronomy, and I thought it was such a cool mission. But when I later read this book, I later found it's by David Grinspoon. I think you know him well. He has a podcast nowadays. He's an important scientist at NASA. Venus Revealed, and I just read some parts of it, and he said actually he told about the first day after it entered orbit, and it didn't go so well. But also, this probe was created from all kinds of spare parts. This octagonal ring at the center of the probe here is actually the service bus of a Voyager that they had spare part of. And there were all kinds of other spare parts of other missions they put on. And when it got at Venus, well, it was able to create these beautiful radar images of the planet, so it worked well. But unfortunately, as David Grinspoon writes in his book, it managed to wander off sometimes. It didn't look at Venus anymore, just started to go look at somewhere else and wouldn't respond. The antennas wouldn't be pointed to Earth. So everybody was very worried what was happening. And then it suddenly was back into view, and they could communicate with it. They could tell, hey, get back to work. And this already happened on the first day after orbit insertion. So scientists and engineers were very worried. Normally they cheer and high five that they're successfully in orbit. And here there was not such a party, because what is happening with this thing? It turned out there was a software bug. This kept happening for several times in a year until somebody found out what was wrong with the software, and then they managed to solve it. And after that, it was active for 3 more years until 1994. It created radar images, and from these radar images, you could also create 3D images like this one. And back then, I can tell you, on my 386 PC, 3D was all the rage. It was so cool to download these images of Venus like this, and they managed to map the whole planet, almost the whole planet, something like 94% of the planet. And what they found were volcanoes, and a lot of volcanoes. So turns out Venus has volcanoes all over the place. But we didn't know whether they were active or not. But what we did know, that whatever was happening, there were some geologic changes, because Magellan observed some areas on the planet twice, and they saw very small variations of the surface features. So, okay, that was that, and then nothing. No. It took until 2006 when anyone else started to get interested in Venus again. They were the Europeans with the Venus Express. They went to Venus in 2006, and they had a whole swath of new cameras and spectrometers to observe Venus. And they found out all kinds of new stuff. So one of the things they found out with their infrared and ultraviolet cameras is that there's a weird standing wave in the atmosphere of Venus. So again, the atmosphere of Venus is moving pretty fast, but what is creating a standing wave? They didn't know that at first. Excuse me. They also found out that there is air glow at the night side of Venus. You have the sunlight that is breaking down carbon dioxide on the sunlit part of Venus, the day side, and from it, free oxygen atoms are created. And when they get back to the night side of Venus, they recombine to oxygen, and this creates light. It creates air glow. I know a couple of friends observing Venus with their telescopes right now. They do a lot of they try to view the dark side of Venus because they say they can see some features in the night side atmosphere. And actually, it's now getting better to see the night side of Venus because it's very close to Earth. And like I said, the phases of Venus makes the dark side pretty big at this time of the orbit of Venus. It also Venus Express also found out that while they thought that the sulfur dioxide concentration was getting lower on Venus, suddenly there was a peak when Venus Express observed it. And why is that interesting? Because sulfur dioxide is getting free when you have active volcanism. Still, this wasn't proof, but the proof came only recently because Venus Express also observed the components that the surface is made of, and it found with an infrared spectrometer that some of the lava plains on Venus there was olivine. And the interesting thing about olivine is, well, at first we didn't know if it was interesting until recently they put olivine in a lab with Venus-like atmosphere conditions. So they created a lab where there was this high temperature, high pressure, and probably also sulfuric acid raining down. And what turns out to be is that olivine reacts pretty quickly, in a matter of weeks, days, weeks, to something different than olivine. So when you find olivine on the surface, it's probably only put just there. It cannot, they calculated it will probably not be older than 1,000 years at the most. So geologically, astronomically, that's a blink of an eye, less than a blink of an eye. This is pretty new. Another interesting thing that Venus Express found were these strange dark streaks in the atmosphere of Venus, and they didn't know what that was. But later on, it was calculated that these particles that create these dark streaks, they are the size of microbes, bacteria. It doesn't say that they are bacteria, but it's intriguing, and we should find out what it actually is, because and by the way, wouldn't that be strange on a whole planet to have life? But actually, this is in the upper atmosphere, something like 40 to 60 kilometers altitude. So that's where the temperatures are more, well, not Earth-like, unless you're talking about a very hot desert in Saudi Arabia or something. But it's pretty hot, but not crazy hot like the surface. So bacteria would be able to live there. So we definitely have to look into that, because wouldn't that be interesting? There was one more Venus probe, and this one is from Japan, Akatsuki, and it was launched in 2010, and it was supposed to go into orbit pretty soon after that. Unfortunately, it had a new type of engine to do an orbit insertion, and orbit insertion is also always a tense moment for a space mission. And unfortunately, it broke down, and the Venus probe didn't go into orbit around Venus. But it didn't give up, and they found another way to get in orbit 5 years later. And now it's there. It's still active. It has a couple of instruments doing still interesting things. And actually, I can show you some images from Akatsuki. This is the infrared camera of Akatsuki. So you have to imagine Akatsuki is in a much higher orbit than intended, unfortunately, because if it was originally intended orbit, it would be even better. Okay, you take what you get in a space flight, because space is hard. And this is what it looked like in infrared. So you can see all kinds of movements in the atmosphere. I have more. This is the night side of Venus in infrared. You see all kinds of turbulence going on there. So that's interesting. And I also found out that these standing waves in the atmosphere of Venus, they're probably have something to do with the surface features on Venus, because some mountain ranges seem to cause these standing waves. So not sure that Akatsuki solved that problem, but otherwise it was Venus Express. But they found out later on. And this is an animation created by Roman Tkachenko. Sorry, my Russian is also a bit rusty. I just don't want to. You don't want to miss out on this one. He created this recently on Twitter, and I asked him if I could show this, and he said, "Yeah, sure." And this is what it looks like. I'm just going to show you the second time because it's so cool. Venus, the Venus atmosphere rotating. It's not a planet, probably here. So that's pretty cool as well. So that was, oh yeah, and here we go another time. Well, okay. Just for fun. 3 times. And, okay. So what about the future? Well, we have future plans, but it's probably not this. This is, these are stills from a BBC documentary where an international crew went on a nuclear spaceship around the solar system to visit all the moons and planets. And just for good measure, the Dutch cosmonaut on board with an American astronaut went to the surface of Venus just for science, probably. It's not, and then they went back with this rocket, which I would never do that because I would probably get up high with a balloon and then have a rocket. But who am I? I'm not a scientist or an engineer like that. Anyway, it was a cool documentary. Space Odyssey, I think it's called. But in reality, there are plans to go back to Venus. For example, India has plans to go in 2023. Haven't heard a lot of it recently, but it's going to be an orbiter as far as I know. And knowing the Indians, India Space Agency, they might discover things that nobody else has discovered up to now. They're pretty good at that. Then NASA also is thinking of going to Venus. For the next Discovery mission, they had selected 4 missions, 2 of them Venus probes. So we have Veritas, which is a new radar mission that can probe the Venus surface in much higher detail. And I'll set myself a little bit to the left so you can see Da Vinci Plus. Da Vinci Plus is a lander. That's a long time ago that the NASA actually put a lander through the atmosphere of Venus. This is a mission to find something out that we really want to know for a while. We want to know if there's any water in the atmosphere of Venus. Why do we want to know that? It's because scientists are getting an inkling that Venus had an ocean in its early life. So that's pretty interesting. Another planet in the solar system that might have had oceans long time ago, just like Mars. And it would be interesting to know why it lost these oceans. We get to know why Mars lost its oceans. But what happened at Venus? The Da Vinci Plus also will have a camera. They have the same camera that the Curiosity rover had when landing. They had these shots of the lander being put on the surface. Da Vinci will have that same kind of camera, so it would be nice to have that view of Venus for once. What else? I put myself to the right again. The Russians, they have plans to go back to Venus, and they have plans, they have had these plans for Venera D for a long time actually now. But they don't want to do this alone. Venera D, it will have a Venera lander, just like the old ones, but one that can survive the time on the surface for much longer, at least 5 hours, which is still pretty short. But hey, you get what you try to do as best as you can. But they said they didn't want to go alone, so they talked to NASA if they want to join this mission. I'm not sure if it really worked. They talked to the European Space Agency, ESA, and they're still working on it, and it's now delayed until 2029 to 2031. Paul, civilization that lived on Venus and caused severe global warming, so they all perished. Yeah, maybe. They did it pretty bad. They did a pretty good job at making Venus into a hellhole. That's for sure. If civilization did that, that's pretty thorough work. Let me put it like that. Yeah. One more thing. NASA doesn't have any very concrete plans to go back to Venus, but they did create computer chips that can actually survive for a long time in Venus conditions. These chips aren't made of silicium, they're made of silicium carbide, and they put them through tests in the Glen Extreme Environment Lab. I'm not sure where that is in the United States, but these chips that they created, they could in a test they survived 167 days at Venus conditions. So at conditions of 500 degrees Celsius. That's pretty amazing. I show you the images on the right side. There we go. So here you can see the chip. So these are pretty simple computer chips. Don't expect to run Windows 10 on these chips yet. We're starting back from square one with creating computer chips with this type of chips. But this is not just interesting for spaceflight or finding things about Venus. The aerospace industry is actually interested in these as well, because you could have chips running in find sensors in turbine engines of aircraft, for example. Which they find pretty interesting. So we'll hear more about this, I think, but it will take some time. But until we find a way to create computer chips that are more complex, the Jet Propulsion Laboratory is actually working on a idea of a concept of a Mars rover that works completely without computer chips. It's a rover that works completely on clockwork and start kind of a steampunk way of going to Venus. And recently they had a competition. You could write in to give ideas to how a sensor might work with this type of mechanisms. So completely mechanical sensor. And we'll learn in June who has won and what it will look like. So you needed a sensor that could detect whether the rover would bump into a rock or go down a big steep slope or something, so they wouldn't run into any problems with it. It's all kind of nice and fun, but there aren't any concrete plans to put this on Venus yet. So they're just thinking about the concept. And about talking about thinking about the concept, NASA in 2015 also wrote a paper about how we could go to Venus on manned missions. Now, I wouldn't sign up for this yet, but the idea is that you could create a balloon platform at altitudes of something like 50 kilometers altitude, where the temperatures are, like I said, not that crazy, but still 70 degrees Celsius. I don't know how much that is in Fahrenheit, but it's below the boiling point of water, but still not nice vacation weather. Let's put it like this. There's still also sulfuric acid in these clouds, so that's also the thing. But they came up with how a balloon platform could work, and you could have astronauts go to that with a balloon with a rocket beneath it. And when you want to go home back to Earth, you release the rocket, and hopefully it gets lit, because otherwise you get down to the surface, and that's where you don't want to go. And the rocket would then launch your astronauts back into orbit around Venus, where probably a space station or another spaceship is waiting for you. And there have some more images about that. So that would be looks something like this, and of course they haven't these spaceships yet worked out, but okay. Yeah, and of course when you're walking on the platform in your spacesuit, you don't want to fall down. That's pretty sure. That's for sure. But interesting thing about this is that it's actually it's not as crazy as it sounds, because at this place in the atmosphere of Venus, you're actually better protected from radiation, from cosmic radiation and solar radiation, than on Earth. So this is almost the only place in the solar system where you can have a pretty healthy environment for humans, except then what happens when you fall down. So one more topic about Venus before I close, and that is terraforming. I've been reading about this in astronomy books. I think Carl Sagan had some written about this back then. I think his idea was, okay, if we want to terraform Venus, maybe we can send algae and spread them around in the atmosphere. The algae would then convert carbon dioxide to oxygen, and when we would have more of that, we only needed some kind of mechanism that would remove the sulfuric acid from the atmosphere, because we don't have any algae that do that. And then the idea is gradually later on things would get a little bit more livable on Venus. It turns out later on other scientists have done some calculations and said, well, it's not that easy as that. And there was a video by Isaac Arthur's Future Space channel. Just look up Isaac Arthur on YouTube. He had a whole episode about terraforming Venus, and it turns out you have to smash a couple of comets into Venus just for starters to start with this, and then you can make it cooler and cooler, and you can actually make it really cool, cooler than Earth, and then maybe you can survive as human beings on the surface. It doesn't sound like it will be a fun place in any way, but at any rate. But well, it's well, who knows what humans come up with in a couple of next millennia, and who knows where we'll get with Venus in that time. Well, this is about everything I know about the planet Venus that I would like to show you and talk about. And yeah, this is the end of my story about Venus. So I hope you had fun, and if you have any questions, let me know in the chat. I will be around. But first, I'll take a little tea, cold tea. I should have put an the end slide at the end of my presentation, but yeah. Terraforming is basically as far as you can go. So if anyone has any questions or so, let me know, and otherwise I will stop the streaming. And oh yeah, that's the dark screen. Wait a minute.